And take a look at our second example. This one's already solved for y. So I just have my domain that I'm going to be using with this function, x squared plus x. So let's see what happens when I start to fill this in. First thing I'm going to do is write down my domain down as part of my table of values. -2, -1, 0, 1, and 2. Now the function is x squared plus x. So if I do f of -2, that's going to be -2 squared plus a -2. Somebody, if I do -2 squared, what do I get? Positive or negative? Positive 4. And then if I add -2, that takes me to just 2. So the ordered pair is going to be -2, comma 2. I'm going to rewrite this function down here so I remember what I'm doing. So I got to do it a bunch of times here, guys. Now let's go ahead. Let's tackle -1. So f of -1 equals, and let's see, so -1 squared plus a -1. All right, let's see, -1 squared, that's, sure, positive 1 minus 1, give me 0, right? So that -1 comma 0. Let's see, go to the next one. F of 0. So 0 squared plus 0. That's easy, 0.
I don't get it.
What part? Okay. I have here's a quick question. Am I still do I still have a function? Is that okay? I have two x's, both lead to the same y. Is that okay?
Yes.
Yeah, that one's okay. It's the other way you can't do. So let's go ahead and get the last couple of these done. So 1 squared, that's just 1 plus 1 or 2. So 1 comma 2. And I'll put positive 2 in. So that gives me 2 squared plus 2, so that's 4 plus 2 is 6. Before I grew, yeah. This is my way of saying I'm going to take the function of x is this. What I want to know is when I replace x with -2, what do I get? So I replace this x with -2, this x with -2, and then I evaluate it. And like this here, f of 0, that's saying put 0 in for x and see what you get. So put 0 in for x, put 0 in for x, 0 squared is 0 plus 0 is 0. So this is just a way of writing down a notation or reminder. Take this rule and replace x with a number. The function. And I'm going to plug in for x some specific number. Yeah. All right. Now I'm going to go ahead and graph these. So at, guys, -2, I have 2. At -1, I have 0. At 0, I have 0. At 1, I have 2. And at 2, I have 6. So those are my points. Now I'm also going to write down domain. I want to write that out as something in brackets and range as something in brackets before I call this problem finished. Let's see, the domain, that's given. So I'll write that down as kind of a freebie for you guys. I'll call on one of you to come up with my range. Actually, let's do a volunteer. What do you guys, somebody, what's my range going to look like? Sasha? 0, 2, and 6 will be my range. The actual numbers I use for y when I graph it, the outputs, are my range. And since I had just these inputs, these are my outputs. Now, is this a continuous or a discrete function? Discrete, because they're just dots. I had a limited number of inputs. I have a limited number of outputs. The dots create my graph, and it's a discrete function. Write that down as a reminder of that keyword, discrete. And then if I want to help illustrate what I'm looking at, I can draw a dotted line to show the curve. But I don't want to make a solid line because that would imply it's all those other points. So that's a dotted line to show that it's discrete. What questions do you have on this that I can answer? Or try to answer? Make a passing resemblance of answering. Pretend to answer.
You want us?
Not answer but sound clever while I do so.
Okay, do you want us to do the dotted line?